A very good morning to all of you. My name is Aditi Arora, Assistant Professor in CEC Department, ABES Engineering College, Ghaziabad. In today's lecture, we will be discussing about page replacement algorithms from the unit Memory Management. Before going on to the topic of page replacement algorithms, first we need to have a quick revision of the concept paging and virtual memory. So, what is paging? It is a storage mechanism which helps us to retrieve the process from the disk, that is your secondary memory, to the main memory, or we can say the primary memory. We all know that our process is divided into equal sized pages and our main memory is divided into equal sized frames. And we also know that page size is equal to the frame size, right? So whenever we need to transfer any process from secondary memory to the main memory, we first divide the process into pages and all of these pages get accommodated in some or the other frames of the main memory. And this mapping is generally done with the help of a paging hardware that is called as Memory Management Unit, or we can say MMU. Coming to the next concept, that is virtual memory. We all know that virtual memory is also a storage mechanism which is used to solve the some of the limitations associated with the main memory, that is its limited size. Basically, virtual memory provides the user an illusion that it has a very large memory, main memory available to it, and it can store any process of any size in the main memory. So irrespective of the process size, one can store the complete process in the main memory instead of having the limited memory size. So by using virtual memory concept, we can actually increase the level of multi-programming. And we also know that the virtual memory is being implemented with the help of demand paging. Now, what is demand paging? It is a process of bringing the pages to the main memory from the disk when needed. So instead of loading the whole program once at a time, we can bring some of the components of a particular process that we need at a particular time to the main memory from the secondary memory. And this can be done with the help of the concept of virtual memory. Main topic of this video, that is page replacement algorithms. There are basically three most popular algorithms that we study. The first is first in, first out page replacement algorithm, that is FIFO. The second one is optimal page replacement algorithm. And the third is least recently used page replacement algorithm, and it is also named as LIU. So first of all, we will discuss about first in, first out in detail with the help of an example. So first of all, what is first in, first out page replacement algorithm? Now we can understand this with the help of an example. We are given a reference string. Now, what is the meaning of this reference string? Okay, if the CPU is executing a particular process and the components of process, so we can say that if the CPU want to access a particular byte which is stored in the page number 6, so the reference string or the reference page will be your 6. So these are the page numbers that will be accessed by the CPU in this sequence only. So how do we implement page replacement algorithms? Where does they come into picture? Let us see with the help of an example. So initially, we say that we have some fixed number of frames. Let us say we say that frame number 1, frame number 2, and frame number 3. Now in total, we have these 20 references. So we can make 20 such frames. FIFO page replacement algorithm is the one of the basic page replacement algorithm, and it says that you need to replace the page which is the oldest among all the pages present in the given number of frames. We can also do the numbering. The basic purpose of page replacement algorithms is to increase the performance of the system and to decrease the number of page faults. We will discuss about page faults. Now, we have initially 3 empty frames present in the main memory. So whenever the CPU asks for the page number 6, it will first find whether this page number 6 is already present in any of these frames. If the page number is not present, we will bring that page from the disk to the main memory to one of these frames. So we can place the page number 6 here. Now, we already understood that page number 6 is not initially in any of these frames. So we can say that there is a page fault. Page fault means when we do not get the desired page in any of the frames, then we say that it is a page fault and we need to bring the required page into the main memory. Now, secondly, page number 1. Again, we can see that page number 1 is not present in the initial frames. So we can say we have another page fault and we will bring this page number 1 from secondary memory to these frames. So we have another page fault. So for page fault, we can write it like this, F. And for again, this is your F. Now, again, page number 6. Now, CPU will again want to access the page number 1. So we can say that page number 1 is already present in one of the frames. So there will be a hit. So we can say 1 and it will be a hit. Then coming to the next reference, page number 2. We can see page number 2 is not present here. So we need to insert that page 6, 1. We have only one frame empty left. So we can place it here. So there is also a fault. Now coming to the page reference number 0, we can see that page number 0 is not present in any of these frames, and also not any of the frame is empty. So we need to make a space for the incoming request of the page number 0. Now here comes the role of the first in first out page replacement algorithm. First in first out algorithm says that replace the page that you brought first into the frame. So as per this frame allocation, we can see that we first bring page number 6. So we will replace page number 6 by the incoming page number 0. So here we will use the page replacement algorithm and there will be a fault because already we couldn't find the page number 0. Next is page number 3. Now, again, we need to apply the page replacement algorithm, that is FIFO algorithm. So here we will replace page number 1 with page number 3. For page number 4, we will replace the page number 2. Again, we are referencing 6 again, but now we don't have 6 already in these frames. So again, we need to make a free space for the page number 6. So what we will do, we will replace the oldest page, that is 0. We just replaced 0 with 6, but now again we need page number 0. So we have to bring it back to the main memory by replacing it with the page number 3. Next is 2602. In place of 4, we will fit the page number 2. Then for 1, we will replace it with 6. For 2, then we will replace 0. Sorry, 2 is already present, so there will be a hit. Now, for 1, 1 is already there, there will be a hit. There is a hit. Again, for 2, there is a hit. For 0, again, there is a hit. For 3, now we need to replace the pages. So, we will replace page number 0 with the incoming page 3. Again, so there will be a fault. Then, for page number 1, we already have one page number, so there will be no page fault, there will be a hit. And for page 2, again we will be having a hit. For page 0, we need to replace which page? We will replace page number 2. So this will be the scenario, right? So in this way, we can now calculate the number of page hit and number of page miss, or we can say page fault. So in this example, if we count that the total number of page hit it will come out to be 8 and the page miss will come out to be your 12, right? So the ratio will be 8:12, that is 2:3, that is your hit ratio, right? So this is how FIFO page replacement algorithm works. The motive of every page replacement algorithm is to minimize the number of page faults. But now we will see one major disadvantage of the FIFO page replacement algorithm. Now, the foremost disadvantage of FIFO algorithm is that it suffers from an anomaly called as the Bilady's anomaly, which says that if we increase the number of frames, by default, what should be there? If we increase the number of frames, then the number of page faults should come to a downfall, right? The number of page faults should decrease. But in the case of FIFO, for some specific reference strings, it has been seen that if we increase the number of frames, the page fault also increases. So it is very important concept, and only the FIFO algorithm is there which suffers from the Bilady's anomaly. Now, how we can mitigate this anomaly? To mitigate this anomaly, we can use some more advanced page replacement algorithms such as LRU and optimal page replacement algorithms, which we will see in the upcoming videos. So this was all about the FIFO page replacement algorithm. If you have any doubt, you can comment in the comment section. Thank you.